Welcome back to another tutorial of CesiumJS in the JS World Academy. In this video, I'm gonna talk about 8 different topics. The first one is getting started with CesiumJS, setting up your first viewer, how to add 3D tileset and resources to CesiumJS, clamping CityGML models to train in CesiumJS, advanced styling and filtering of 3D tiles in Cesium, visualizing LiDAR point clouds in CesiumJS, integrating beam models into your CesiumJS visualization, creating interactive movable object from 2D data in QGIS or any type of WebGIS tools, and finally adding real-time dynamic entities to CesiumJS with the power of RESTful APIs. I want to say a special thanks to the Cesium to support this series of tutorial, and if you are excited, let's get started. Here is the result of this tutorial. We will code together how to give different type of style to our 3D tiles like this based on the roof and terrain. We will try to add a point cloud in our front end application. You can see how perfectly all of our point cloud with acceptable speed is rendering and loading in our front end application. Then I will tell you how you can filter them, for example, based on the classified or labeled point cloud data. Here is the water and here is the tree. Then I will just zoom to this area. Then I will load my beam data. You can see you can edit, you can show, or you can invisible it. Okay, easily. Then also you can add your point cloud. Yeah, it's absolutely fantastic. You can see how it will be visualized, or if you want to build something new, does it have any effect on your vegetation or green area or not? Then we can use the Google Photorealistic 3D tiles. It's absolutely wonderful. It is exactly same as you can see right now the combination of Google Photorealistic 3D tiles and the point cloud. It is exactly same that you have in the Google Earth, Google 3D models. So, but you have the complete package in one application, so you don't need to jump from this application to another. So I will turn off. Then you can add uh, the 2D data, for example, right now, the path of this drone, or how we can name it, or UAV that start taking a photo from this image. So you can generate all these things for different applications, for the agriculture or applications. For example, you want to monitor the path of the UAV, you can show it to your customer before, for example, getting the project or something like this. And then the most exciting part right now that I wanted to show you again, the connection of the CesiumJS API to the models. So maybe with the 3D data, a lot of people, for a lot of engineers, it's a little bit difficult to work with them. So with one click, you can see now, you can visualize the traffic informations with real object models. So if they are connected to the time, or if they are connected to the coordinates, you can easily visualize them with the RESTful APIs. So, for example, right now here, this is a car. So here we have an accident. It's absolutely fantastic. So instead of this bus, maybe I can just open my WebGIS application, and you can see I will just easily click on it. Then instead of the bus, I will change it to the car. And instead of the first car, I will change it to the bus. Save it, then just refresh the applications. You see, this is the bus, and this one converted to the car. Or maybe you can just remove it, or you can connect it directly to the QGIS. Okay, you can see this is the updated data. So then I will click on it. Maybe I don't need anymore, maybe this car and this one. So as soon as I am deleting such a things, so back to the browser, refresh. Oh, sorry, I shouldn't refresh it. Yeah, but anyway, it's fine. So again, back to the model. I will just refresh it and zoom here. You can see that. Where is it? Yeah, now I have just this car. Yeah, it's absolutely fantastic. This is a super easy applications. So you're connecting whatever you have from the 3D tiles, point cloud, and 2D data. So if you are excited, just let's start coding together. Here is our folder structure: start, final, and data. So when we finish this tutorial, I will push the final all this package to the Git repository. You have all the code, and I will add the link in the description below. And then also, if you want to code with me, open the start file in any IDE or editor that you want. Just start coding me and have fun with coding in CesiumJS. Also, I have already added a bunch of data. It is one of definitely a challenges working with 3D data, because definitely you cannot find different type of data. I have already gathered all of them there, from the point cloud data, from the, I don't know, beam data, GLB data, and also CityGML data, and also some static points if you want that I generated in the QGIS. And also, according to all these steps, maybe I can just open the code in the PyCharm. I'm using the PyCharm. You can use anything else. I'm using the JetBrains, so we can open it in anything that you are familiar with and you like to coding. Okay, so here you can see this is the structure of the code. We have a separate video for all of these steps, but if you want to have everything as a complete package, just follow this tutorial and you don't need anything else. Okay, we have different type of to-dos. You can start with each of them by yourself, or we can code together. Okay, let's start. Index.html file. So you can see this is a very simple index.html file. I don't wanted to spend the time to tell such a things to you. I hope you know about it. But again, if you have any questions according to how to create such a things, just comment it in the comment section below. I can create again a simple tutorial for that. So we are using Webpack for this tutorial, so also I have a complete how we can install the Cesium with the CDN and Webpack. So both of them, I think it is in our part 3 of the videos, so you can take a look at it. So npm start. Okay, so let's just check what is the status of our code right now. So here you can see I have just a button with these static buttons. So these buttons don't do anything. Yeah. Okay. Back to the code. The first step I wanted to do, back to the index.js. The first thing is in access token and viewer. In order to create an access token, you need to create an Cesium IN account. To do so, just jump into the Cesium.com website. It is completely free, so you can it is super easy. Just need one email and then one password, and everything is done. So after that, when you click on the Cesium IN, so first of all, maybe I can close it. So you can see such a perfect and great user interface. So you can just go to the asset files, then you can upload whatever you have. I will tell you all these things later. So before that, we wanted to talk about access token. So for creating an access token, here you can have a button, access token here. So in the access token, you can create for different type of your applications, some status app. One of them is the default access token, and also you can just make with different type of the permissions. It is a write, read, and so on. For example, you want to let someone to download your source data or not, such a things. Okay, perfect. So here your access token, you should just copy paste it And if I back to my code, you can see I have a Cesium config file, and I have already, what is that? Okay, I define an access token and I pass this access token to this variable. Okay, I think this is the most easiest way instead of hard coding inside the index.js, but it's up to you. Then, okay, it's done. Maybe we can just initialize it in our code. Let me just open once more PyCharm. Then I will back to the index.js. So the first thing is I'm using in. So first of all, I will import in from the Cesium, and then from that default access token. So equal to, it's easy right now. I have already the access token inside the Cesium config file, and I have already exported. So I will import it easily in the index.js. The next step is creating a viewer. So const, so viewer equal to. So we need to create a new class or object. So from a viewer class. And then when you are creating a viewer class, you should assign a div. So back to the index.html. Here we can see that you have a Cesium container. So here it's assigned to this div. So and then it has some classes, CSS classes. Then we should define it that this viewer should connect it to this tag. Maybe I can just grab the ID so I don't need to type it again. Then after that, also I wanted to see the Cesium train model. So I need to open the braces, or I need an object. So it is a train provider, and then I will use await. So before this line is completed, I don't want it to other lines to be run, and then create word train async. Control S. Perfect. So maybe we can check our implementation up to this point. So it was this one, our application. Let's just refresh it. Perfect. You can see this is the beautiful word. Maybe I can just zoom in somewhere. So then you can see that our Cesium train also works perfectly. You can see, yeah, it's fine. Or another thing that I have also explained it to you in our first tutorial, it's this page, CesiumJS quickstart. With the CesiumJS quickstart, you can have access to a bunch of the codes. Okay, for example, this one. So this is fly a camera to the San Francisco. I will just drag and just grab this part of the code, paste it there, Ctrl S. So here you can see everything is loaded from the Cesium. Yes. So if these things are coming from the Cesium, it means that all these things are connected to the CDN. So maybe I can just take all of them. I don't need them. Back. Ooh, ooh, ooh. So here I made one mistake to select. Perfect. And now I need to import the Cartesian 3 and also math. I don't know why I cannot import it, so I will add it manually. Then back to the code, just refresh. Perfect. You can see that here is the Cesium ion and here is the San Francisco. I have already told you how we can also add other 3D tiles in other tutorial. I don't want to repeat them again here. Perfect. So then now it's a time to talk about what is the resources and also how you can add different type of assets to your CesiumJS project. Here is the Cesium IN. So As I have already told you, once you create an account, you will redirect to this page. So in this page here, we have a button which is called Add Data in the My Asset tab in the Add Data. So for example, we can do one together. For example, this bus station. So this is a GLB data. Then it is up to you how you can make it as a different type of data format. I will make it as a GLTF. So in that case, the center of the objects, so the center point for the rotation and everything, it is the center of the object. So, and then just if you wanted to make it downloadable for others, also you can add these options, but I wanted just to upload it. You can see it is super easy. Then all of your data will be gathered in one place and it can make your project uh, as flexible as possible. So you know that all of your data is there, so you don't need to store it again and again on your local machine or on your own server. Yeah, you see, it's done. So here it's my 3D object, and it doesn't matter you built it, you buy it from somewhere, or you download it, or you make it by yourself in the Blender or any other type of the 3D object generator software. Okay, yeah, it's done. So for example, this is a bus, this is the bus station. So this is the same thing. Maybe I can just remove it because I have already uploaded it to my Cesium IN. This is a tree. You can see after a short period of time, you will have all of your 3D object models. So another fantastic things you can upload the LOD2 data. So this is the LOD2 data that we should work, and you have it in the folder, in our folder directory. So in the folder of the data. So here you can see that these are the 3D tiles. So the power of the Cesium is tiling and the data. So you can see that according to your zoom level, according to your other type of the data, for example, you can see in this level, you don't see this data. So with this option, all the data will be rendered as fast as possible on a user or end user browser. So then also we have a point cloud. Then point cloud is a little bit challenging sometimes. So here on the top you see a button, so adjust tileset location. So if you add a point cloud, then your point cloud has some problems, then it is possible that you wanted to relocate it. So here you have a three arrows, so to the z, to the x, and to the y directions. So in that case, you can easily, you see, you can easily change the location of the point cloud. So you can see, perfect. And then you can adjust your point cloud in case that your point cloud it's not georeference or the points are doesn't have the correct coordinate. So you can do that. So right now, I don't want everything for my point cloud is fine. Then I will reset it. Okay. So this you can see this is a super easy thing. Then after that, if you cannot find it, just with one click, you can zoom to the tileset. See, these are exactly the same thing that also we can implement it in our Cesium web project. It's done. Then then you have some these numbers. So then I wanted to back to the asset, close without saving. Perfect. So in that case, right now, I wanted to save all of these INs. Let me back to the code. So inside my config files, I create an asset ID, and then I transferred all of these asset IDs here in an object. So, and after that, I export it, then I will import it to my index.js file. So right now, we don't need it, this part. So I will just remove it, easy. Then the next part is, so index.js file. So in that case, we should create our assets and resources according to our to-dos. So the resources and the tile sets. So what are the differences? So first of all, resources are those things, for example, these bus station, the tree, and all these things we are naming it as a resources. And the tile set are the data, for example, the CityGML data when you upload and make it as a 3D tile, or maybe your point cloud data, or these Google photorealistic thing. So we call name tile sets. So in that case, I will create and const, and I will name it as a resources. Then I need to create uh, an object, and then the first thing is aircraft. So that things that it wanted to go around the building and take a photo and make a 3D of the building, yeah, the real world application. So in resource dot from asset ID, then asset IDs dot aircraft. Great. Then it's easy. Just I will duplicate this line, and instead of the aircraft, I will just write bus, and instead of this one, I will just write car. Then here it should be bus, and here it should be car. Easy. So our resources is ready. The next part is adding the tile set to the viewer. We will do exactly the same thing. I will create again a const tile set. Then again we need an object. In the object CityGML. So again we are using a weight from Cesium 3D tile set. So first of all, the 3D tileset class, then from asset ID, asset IDs dot CityGML. Great. Then refactor the code and save it. Then the only thing I need, I should duplicate it for point cloud, beam, and Google photorealistic. So this part will be point cloud, or I can make it here as a point cloud. Then the next one is beam. Also here it should be beam. Then here it should be Google photorealistic. I grab it and also paste it here. Perfect. So tileset also it's done. The next part is we should right now we should add the tileset into the viewer. So it's not really complicated. So first of all, I will create an array. So in that case, tileset dot CityGML. So in that case, I wanted to add the CityGML, point cloud, and photorealistic inside the viewer. Exactly same exactly same we did for this uh, fly to something, but we want to show the data right now. Tileset dot point cloud, and finally tileset dot Google photorealistic. Then for each of them, we want to uh, run this part. So tile set, then equal, then we should say that viewer dot scene dot primitives dot add tile set. You don't need to memorize all of them or write the code from memorizing things. So after writing some codes in the Cesium, everything will be easy, clear for you. Okay, so maybe we can test our implementation up to this point. Back to the browser. Oh, okay, so I forgot something. Right now we have already added the tile set, but we didn't didn't tell to the viewer where you should go and zoom to it. So in that case, also it is easy. Again, I will use await, then viewer dot zoom to. And you remember about that we click on a button and it was zoom to the tile set. So in our point cloud. So this is exactly the same thing. Zoom to tileset dot we can say the CityGML point cloud beam anything, but I wanted to zoom to the CityGML right now. Okay, let's look at the implementation up to this point. Okay, yeah, it looks fine. You can see right now you are importing all the photorealistic point cloud, the CityGML data. Yeah, so our code is working properly. Then let me just close it once more, and then we are adding something else. Tileset dot point cloud dot show equal to false, and also tileset dot Google Photorealistic dot show equal to false. Perfect. Then once more check the implementation. Great. Yeah, you can see now just I have already imported the building. Right now, let's activate these buttons in our code. First, I will create an object uh, or I will create an instance from tile style manager. Okay, let's do it. So const style manager. So then it should be equal to new tile style manager. The input of tile style managers is tile style CityGML, tile style tile set. So it is tileset dot CityGML and tileset dot point cloud data. Okay, first we will work with the CityGML. After creating the instance, then from the style manager dot so train the style. Okay, let's check our implementation again. So if we see that the buildings got any color or not. Yeah, perfect. You can see that now all the buildings are colored according to the height. Yeah, so in that case, if I click on this building according to this height, this is 103 and this building is 104. Okay, let's again check the code. So here we have tile style manager. So we wrote a code, a class, which name is tile style manager. It has it always two inputs or constructor, tile style CityGML and tile style point cloud. So we have already defined it. It has a apply style and generate colors. Here it is the terrain height style and roof type style. What is this? First of all, we have some conditions. So again, go to this one. So here you can see that we have the again two objects and again with the condition. So here is 101, 4, 6, 4, 1. You see that 100, 104. It was 103, 104. So based on these classes, if you back to the code, first of all, you can see that we are counting the number of the classes. According to the number of the classes from the Chroma JS library, we are generating the color. For example, if it is the 6, we are creating 6 different colors. And then after that, It's easy. Now we have a 6, for example. Right now, this is a train height. We have a 4 or 5 different conditions. According to each of them, we are saying that if the number is more than this value, then we are setting that color. But again, let me just tell you how we can give the style. Again, we will back to the Cesium. So in the Cesium, just go to the quick start part, and then from the quick start part, just click on the style and filtering. Then after that down, just try to find a sample. You can see that it is again an object, and here you have a property or a key. So again, property or key of the condition. So it is there inside an array, we have a list of the arrays. Each arrays should define a color. So in that case, for example, if I have a 5 condition, I need 5 arrays. The first part of the arrays always is, so what is this name inside the 3D tile? So let me just back. So when I'm clicking on this object, you can see that it is, for example, train height. Here is height, here is latitude. If you wanted to give a style or according to your condition, you can just use these values. That these values are coming from your CityGML data, but some of them are generated automatically by Cesium when you are uploading the data to the Cesium IN, like this train height, because we are clamping the data to the Cesium train model. Yeah, you can see it's easy. So the same thing, it happens for the roof type. And after that, when we want to apply the style, what we should do for the applying the style, we are using the Cesium 30 tile style. And after that, here is the color. These are the conditions and the show. So we will talk about the show when we want to work with the point cloud. Okay, back to the code. Let's just finish this part. So we add this part. So right now our building has the colors. So let's just activate some buttons. So when we are clicking on a button, so the colors between the train and the roof should be changed. So here just I will write buttons, and then after that document dot get element by ID, and then which ID I wanted to use. So btn roof, then add event listener. So then, and then when someone clicked on this button, then I need a arrow function here. Perfect. Inside this arrow function, just you should call style.manager train height. Oh, sorry. So in that case, btn train. Then I will grab again this part of the code, duplicate it, and then do the same thing for the roof. So here it should be roof style manager. So back to the code. Let's see the result. Back to the browser to see the result. Okay, it's loaded. Roof type absolutely perfect. So we did also this part. Then the next part is how we can activate these buttons. First of all, bring the point cloud or show the point cloud. Right now, everything is there, also the point cloud. You should show it and then give filter and color. Okay, let's do it together. So first we should go to the tile style manager, and then here we should create a class arrow function, class arrow function. So perfect. Then I will just give it the name as a point cloud style. Then sorry, then in the point cloud style I have to define the new I have to define two consts, exactly same as here, the number of the conditions and also a show query that I have already told you before that I want to explain this right now. So first of all, I will create a const. It is the color condition, and then it is equal to, I need a curly braces. Again, inside this array, I need another array, as we have already talked about how to write a style here. So first of all, I need the curly braces, close, open it and close it, and then I will add a dollar sign classification. Okay, and then for the classification, I should add, if our classification is equal to 1, then I need to define a color for that. What is the, then I should just write the color, same as here, and after that I should open the parentheses, and then I have to give the color. For example, right now if it is a 1, so it should be green. I should close it, close the braces. I think it looks fine. Then the only thing I need, I should duplicate it. Instead of 1, I will add 9, and also instead of green, I will add light blue. Great. So our condition is ready. Then the next part is the show query. Show query, it's exactly the same thing. So you should write a query that you should show that I just wanted to filter this part of the code. Again, if you want, we can just open, so definitely we have some errors. So here these are about the styles, and I hope that, yeah, this is the show query. So you see that you should start with the feature, and inside the feature you should add the building, and if something is equal to this one or this one, then yeah. So maybe I can just grab this part of the code. We have already see this, so we should use it right now. Okay, so I need this one, and then I will paste this part of the code. So we have a feature instead of the building. What should I write? Classification. Easy. And then if this classification is again equal to 1, or just I will just take it, copy all, and then paste it here. Again, if the classification is 1 or 9, show the result to me. Yeah, easy. So perfect. And then the next step is this dot apply. And just think about, if we don't add the query, the result will be correct, or why we should use the show query, because if we are giving the colors, it will be green and light blue for 1 and 9. So what is the reason that we are writing a show query? Why we are using the and the filtering? Just, I think from my point of view right now, the colors is fine, so, and the system will works. So what is your answer for that? So perfect. Yeah, that's completely correct. By filtering, you are reducing the number of the points that it should be rendered in the in the front end. So in that case, you are saving a lot of time for the rendering, and you have the efficiency in the rendering, so you are increasing the performance. Okay, back to the buttons. I should write a document dot get element by ID, and then what I have for the point cloud exactly is point cloud, because it is just a true false, as you remember. At event listener, it should be change, and then if it is change, I need inline and inline arrow function. Perfect. So for the inline arrow function, what should I write here? For the inline arrow function, I should first of all take the event, and then after that, when I get the event, I should say that if event dot target dot checked. So in that case, again, I need curly braces. So tileset dot point cloud dot show, it should be equal to true, and also we should give the style manager. So in that case, we are giving some style to our point cloud. Otherwise, I don't want it to show it. Else, so in that case, tile style dot point cloud dot show equal to false. It's absolutely perfect. So let's check it if everything works properly or not. So we don't, thanks God, we don't have any error there. So click here. Yeah, perfect. So our point cloud is there. You see that everything is really good and really fast, although I'm using the recorder software, so I think everything looks really fine. Then the next part is beam data. This part of the code is really easy. So then, as you remembered, we have two buttons. One of them is zoom to and one of them is true false. So just do it. Document dot get element by id. Let's check what we have is beam data, or maybe we can do it the first thing, zoom to beam. Then add event listener. So in that case, when anyone clicked on this button, I need inline arrow function. It's absolutely perfect. So in the inline arrow function, it's very easy. We did it right now. If you remember, for the CityGML data viewer dot, tell me what is zoom to. That's correct. Tileset dot beam. Finish. It's easy. The first part. So you make a button that you can zoom to any type of tileset. So definitely it is one component. You can put it in your code and then you can use it anywhere. It's easy, yes. Then the next part is I have a button. I wanted to click on it and then zoom in, zoom out. So sorry, show true, show false. Exactly like this. So document dot get element by id. So in that case, I should say is beam data dot add event listener. So in that case, we should say it is a change. Yeah, you are absolutely correct. Then we need inline arrow function. Inside the inline arrow function, I need the event. So the first thing we should say that viewer dot scene dot primitive dot add. So what should we add? Tileset dot beam. That's correct. Then the next one is right now it is the first part that we are initializing or adding the beam to our viewer. Right now we should say that if it is clicked, so your button, if it is clicked, do everything vice versa for the showcase. So in that case, viewer dot beam, sorry, not viewer, it should be the tileset dot beam dot show. So we are using one of the perfect functionality of the JavaScript. So whatever it's there, do vice versa. Okay, so event dot, because the first step is the false. So when I'm click on it, it should be true. Event dot target dot checked. And also, if you want, you can easily just write it. If it is true, do this. If it is false, do this. Okay, let's check it. I hope that everything should work perfectly. So zoom is working, so the location is changed. Add beam data, boom, everything fine. And also we add the point cloud. Yes, point cloud also is working, and also this button is working. Okay, let's implement the Google Photorealistic 3D tiles together. This part of the code is easier also than the previous one. So in that case, we should just say that if the photorealistic is, for example, is visible or it's true, then the CityGML or CityGML 3D tiles should be false and vice versa. Okay, just do it. Document dot get element by ID. So in that case is Google Photorealistic. Then add event listener. Again, in that case, we should use the change because it is the true false value and inline arrow function. So in that case, also we need event, and then we should say that if event dot event dot target dot checked, uh, then first of all we should say that Google Photorealistic true, tileset dot Google Photorealistic dot show it should be true, and then tileset tileset dot CityGML dot show it should be false. Perfect. Okay, then I will just grab again this part of the code. It has the else part. Then paste it exactly here. Here it should be false, and here it should be true. Great. Okay, let's check it, and I hope everything should work perfectly. Back to the CityGML Google Photorealistic. Absolutely perfect. So, and then when I turn it on, turn it off, when you see when the tiles is rendered, everything is perfect. Okay, let's jump into one of the most interesting part, adding the aircraft. So a moving object around another object in the Cesium. Okay, first we will activate the button, and after that we will talk about this moving object, and I will explain you how these things will works. Document dot get element by ID. It is again zoom to aircraft dot and event listener. So again, it is the type. It is it's click. Then I need inline arrow function for that. Then I have to create an instance from the moving object, new moving object. The first thing it will be a viewer, and after that it is the flight data. Don't worry about it, I will explain you all in detail. So it is the flight data, and after that I need a interval time between the position align the path as between each position. I will tell you. So I will add just simply one, and then I will pass the aircraft. I will tell you why we need also aircraft. So we have moving object that add movable to the entity. So here we need the resources dot aircraft. Perfect. Let's check if everything works, and then I will explain it to you. Data is loaded. Perfect. Then if you zoom to our building, yeah, it looks fine. So the system is working. So let me the first step. I wanted to explain you how this rounding or the circles are working. Let's open the QGIS, and also I will open my files, and let me just go to the YouTube. Let me just bring it also here. So inside the Cesium part 10, and then inside the data, I have a UAV points JSON. So I will add it here. Okay, I understand it. So then let me just open it. You can see these are all of them the lines. And maybe I can just dock it somewhere. Let me just zoom to it. You can see that these 8, it is the first 8 points. You cannot see them. So maybe from the last, if I can select them, you can see this is like this. And then this is the 45, this is the 44, 3, 2, 1, and 40. And again, it is a copy, copy, and copy. In that case, you need just some points. And then also, first of all, a hard code. I showed you the hard code one, so you can see how everything it simply works in the CesiumJS. Just you need some points. And then after that, I easily just export it as a GeoJSON file. And don't forget to make the coordinate system to the WGS84. Okay, so we don't need it right now. Then back to our code. So here we have the flight data. I just copy paste that one here. You can see that we have the feature, and inside the feature we have the properties, point, and for each of them we have the coordinates. Then back to the most important part, moving object. So moving object, I have a complete again tutorial according to this moving object, so you can take a look at it. It is, I think, part 4 or 5. I will add the link also in the description below, all of them for you. Don't worry about it. So here is the moving object. So the first part is the viewer. So definitely we need it. We need a place to put our 3D object models there. Then we have our path. This is the flight path. I showed you how I created. It is really, it's just copy paste. Yeah, it is not a very professional way, but it's enough, I think, for a tutorial. So you can automate it for the future. So here is the speed. Here is the object type. And I think they are clear. Then we have a config time. In this config time, so we are giving the time to each point. And then here for each position, we are clamp it to the Cesium train by this function. Therefore, you have the updated position. And after that, according to the time step, it means that the interval between each position updates along the path. Okay, so with this one, you are creating a cartographic latitude, longitude plus a time, and then you are passing everything to the position property as a time and position. Okay, and then the next thing is I added a little bit hard coded here again. So it's not really beautiful, but let me just explain you. Here we have aircraft. So in that case, if it is the aircraft, you see that the height of all the points of the UAV in the QGIS, we don't have any height. It is X and Y direction. So in that case, I said that, okay, here it is a for loop. Inside the for loop, just anytime according to the I, according to each for loop, just multiply everything, for example, to 1. So in that case, you are giving 1 meter, 1 meter, 1 meter height to each point. So you have a very smooth going the direction from the 0, for example, to the height of 20. So in that case, you are giving a height to each position. And don't forget, you are again clamping this height to the Cesium train. It is not a surface. So I really like this part, but I don't like this hardcode part. But yeah, anyway. So here it is again. You have already created everything there according to the time, according to the position. And as soon as we are running this function, the object with all those features we added to our viewer finish, and then we are zooming to the entity. Perfect. So it was a very simple explanation. And then in that case, in the future, just you need this class. You should add it to your project and use it and finish. Then you have the moving object models in your project. So the next part, which is really absolutely, I love it, is our 2 to 5 Getting line string coordinates from the API, visualize the bus and the car movement. To start this part of the code, we need the API. Let me just open the browser. So if you wanted to see the complete, so in the previous session part 9, I have already completely explained it to you how to work with such a thing. So GIS Word, then where I should go, then after that I should Cesium. Exactly, Cesium line string project ID equal to part not 9, part 10. Perfect. I do understand that it is not really safe way to just public our APIs like this, but this is a tutorial, yeah? Don't make it complicated, okay? So just take it and then use it and try to learn and understand how you can use different type of APIs in the CesiumJS. So here I have the lines, and the idea is that, let me just open my lovely QGIS. So here you should draw a line, and after that, for each vertex, I wanted to convert it to the line. So here you have 1 point, 1 point, 1 point, and then put all of them in the cesium, and then your object will be moved exactly like these points. Yes, let's do it. So compare with this one, they are the lines, a line geometry, line string geometry, and they are the points. So in that case, we should convert them from the line to the point. This is a little bit challenging part. Okay, so where is my code? Okay, first I have to define const. So fetch all the data. We want to create a function of fetch all the data, but before that, I need the API URL. Line is. You can name it whatever you want. Yes. So API URL is equal to. So I think I forgot to grab it. Okay, and after that, paste it there. Refactor the code, reformat the code, not refactor the code. Yeah, if you want to refactor the code, then yeah. then right now we need arrow function. So I wanted to create an arrow function. I will name it fetch. Naming the function, it is one of the most challenging part. I'm not really good in, but so fetch all the data. Then I'm using the Axios. I'm the fan of the Axios, definitely. So in that case, so for your case, if you have not installed Axios, but I'm pretty sure if you are using the start file, so the Axios has been installed. But anyway, in case that you don't install Axios, npm install Axios. Not this one, this one. Perfect. So Axios right now installed and has been added to our package.json file. Axios dot get, then API URL. Then we should talk about then part. We have inline arrow function. So in that case, definitely I have a response. Then, sorry. Then I should say that viewer dot entities dot remove all. So maybe all of you said, well, why we should do that. Right now, I don't have too much data. According to the experience working with a large amount of data sets, sometimes it's really dangerous, because if you wanted to show the important data like a traffic data or such a things, your data should be updated. If you add any data to the viewer, it has been added, so it is there until you refresh the page, until you wrote the data again. So in that case, removing all the data, it means that you are refreshing. And also it is a little bit challenging part. You can also use remove by ID. So if you wanted to know more about it, just comment it in the comment section below. I can create another complete video about it separate. So okay, response dot data dot features. Then I wanted to use a for each on the complete feature data as we saw right now. So again, I wanted to use inline arrow function, and then inside the inline arrow function, I have a feature. Then I will create a const. So object path equal to convert line to points. Then just I should give the feature and it's done. So what is convert line to points? As I told you, the input of my moving object model is the point. So I don't want it to recode something again or create something new. So why I should do that? But as soon as I'm getting any line with this simple part of the code, I'm converting it to the point. Exactly same as flight data. So there is right now no difference between this part and this part, and it's done. So this is the part, and I think it is easy, and I don't need to explain more about it. Okay, then after getting so the same process, so we should create an instance from the moving object. Then from the moving object, then we should give the viewer, and then we should give an object path. And then, so here, this is again time a step in second. Also, we can use it as so in that case, we can visualize the first speed. So in that case, instead of 1, if I use it 10, so the speed will be faster or slower, it will be slower. Yes. So it means that it needs more time to go from one point to another. Okay, and then after that was you can give it anything except aircraft. So the rest is fine. So moving object dot add movable entities. So in that case, I should give just resource, and then sorry. uh, Okay, so in the resource, I should give the type of the resource, because in that case, it will connect it to the asset ID, and I will grab the bus or car. Feature dot properties dot usage. So I will show you right now, and then yeah, I think it's done. So here it is my moving object, and the next part is after loading all those things, I wanted to say viewer dot zoom to. I think we can also do this. Yes. So viewer dot zoom to viewer dot entities. Yeah, just this. I think it looks fine, and also this is the closing of the then, and also I will write a catch. So in that case, if we have any error, so in that case, please log it in the console. So console dot log error. I think it's perfect. So here is the fetch data. We convert it, and also let me just explain this part also to you. Again, let me open the browser. Here we can see that we have the coordinates, and then we have the properties.usage. I can get it is a bus or it is a car. So I can put different type of the objects on it. Again, great. Then let's go down. Document dot document dot get element by id. Then we have so we have this fetch data exactly. Then add event listener, it should be click, and then after that again I need inline arrow function, and then here I should write fetch data. I think also we don't need this part because also I think I should remove it. Yeah, I think it looks better. So when I click on the fetch button, so all the data should be, first of all, the entities will be removed and then data will be visualized. Okay, let's see if everything works perfectly or not. Great, we have an error because I changed the port, because with this localhost 1818 you can access to the API, otherwise you are not allowed to use the API. Generally speaking, it is not the same thing, but yes. Okay, everything it's loaded. Yeah, perfect. But our cars are really slow. So in that case, if you change it, let me just go to the code. If you are changing everything from the 10 to 5, then everything will be a little bit faster. So let me just refresh the code. Perfect. So we can see that the speed of the car right now it's a little bit faster. Let's again check it with the QGIS. So let me just open the QGIS. Here we have a car. So maybe I can change this car right now. So I will click on it, then edit. Where is my arrow function? I will click on it. Let me just change it from the car to bus. So let me save it, refresh it. I think it's fine right now. It is a bus. Then also I wanted to add a car ahead of this bus in the same direction. So let's try it. So from here to here, 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 and here, I wanted to have a car. Okay, save it. So back to the code. So here you can see right now there is nothing. Just I will fetch the data. Absolutely perfect. This is a bus and this is the car. It's fine. It's funny. Okay, so I think right now we are to the end of this tutorial, and I want to say a special thanks to your time. And again, if you have any questions, don't forget to comment it in the comment section below. I will answer to all of your questions as soon as possible. Also, I want to say a special thanks to the Cesium to support this complete series of tutorial. Then see you all in the next video. Bye.